This clip is on atomic structure and how to draw atoms. First of all, looking at this atom of helium, we can see that there are two numbers next to it. The smaller of the two numbers is always called the atomic number. The larger of the two is called the mass number. Occasionally it's called the atomic mass, but the important thing is that it's got mass written next to it, and it's the larger of the two numbers. In an atom, the atomic number is always equal to the number of protons. Oops. Protons have a positive charge, and they're found inside the nucleus of the atom. Because the number of positive charges has to balance the number of negative charges in an atom, the electron number will always be the same as the proton number. So electrons, which are negative, equal the protons, which are positive. Last thing that you need to be able to calculate is the number of neutrons. The mass number is the protons plus the neutrons together. So if I was to calculate the number of neutrons, I could take away the atomic number from the mass number. In this case, it would be 4 minus 2, would give me 2 neutrons. So in the example of helium here, we would have 2 positive protons, 2 negative electrons, and 4 minus 2 neutral neutrons. To draw that, I would have 2 positive protons in the nucleus, 2 neutral neutrons, and around the outside, in just one shell, I would have 2 negative electrons. Let's try another example, a slightly bigger one this time. Let's try 19,9 fluorine. Same rules apply. We have the atomic number, we have the mass number, and we can calculate the number of positive protons as equaling the atomic number, so that would be 9, negative electrons also equaling 9, because these two have to be the same, and then neutral neutrons. And in this case, I'm going to take 19 from 9 from 19 I mean, and get 10 neutral neutrons. Now in order to draw that, I would have 9 positive protons in the centre, 10 neutral neutrons in the centre, and then following the rules of the electron shells, I would have 2 electrons in the first shell, and then in the second shell I could have 7. 1, 2, 3, 4, 5, 6, 7. So my electron configuration here I would write as 2, 7.